Good evening, everyone. I know it's late. I'm not very familiar to the two-wheeler forum, but I guess that's the benefit of being in the EV space today. Get an opportunity to interact with new audiences all the time. So for those of you who don't know, Green Fuel is our company. By the way, it's last over here, so Rahul, I'm expecting a discount soon on this, what we've got. I just wanted to talk to everyone very quickly because we've been doing lithium-ion battery packs now for the last 2 years. And I get a lot of queries when I go around meeting different people. And I think it's very important to talk about this key component, which is about close to 50% of the vehicle cost. But if you ask me in experience, close to about 90%. Because the reliability and the customer experience both depend on how your battery pack interacts as part of the vehicle. First of all, I'd like to start off saying that it's not a commodity, right? A lot of people say that's what a battery pack is, and I think we couldn't be further from the truth. We are one of the few companies who did not do a technology tie-up, but actually hired expats from abroad to bring in their knowledge and then Indianize the product. And I'm proud to say that we're the only Indian company to have now almost 4 patents on our battery pack. And that's what we believe in, technology. We've seen many specs in the Indian market. And therefore, when I go through these specs and when I go through a lot of them, I really feel that who's making them, you know? And I think it's important to highlight for everybody's knowledge how to specify a good battery pack and what is a good battery system on the whole. So I call this presentation myth versus reality because we hear a lot, and what is it actually on the ground. So, and I promise I try not to bore you over here, right? Not going into too many technical details. Can we roll the next slide, please? Okay, so a lot of these queries we keep getting asked, so I'm going to try and address each one of them. What is the superiority of one chemistry over the other? Form factors of battery cells, battery pack cost, which is a topic when we go to most traditional OEMs, is more important than when we go to the startup side. Cycle life, thermal management, and battery pack development with OEM engagement. This is a critical aspect. Can we roll over, please? Okay, so somebody said earlier that lithium-ion battery chemistries, there are several of them, and that's true. The question is, how do you choose, right? The answer to that is, you really have to decide, and that's the flexibility that an electric vehicle affords you. Are you looking at energy density versus power? Are you looking at energy and power, right? If you're looking at power, you're probably making a performance spike. And the problem is that, you know, who you're catering to, which is your market segment, what is the product, you know, what is your vehicle footprint, all this will decide for us as a battery pack manufacturer which cell to select. You know, I did hear Mr. Bala saying LTO is a fantastic product. Sure, for him maybe, but for maybe someone else it could be high energy density. Or maybe for somebody else it could be just power, right? So we get a question, you know, LFP, NMC, LTO, all this. So I just wanted to highlight each battery cell chemistry has its own advantages and disadvantages. And that entirely depends on the application. Right? I'm not going to go into details of each type, right? But let me give you an example. People say LFP is better, right? Why? Maybe in thermals, but in energy density it's much lower. So are you willing to sacrifice weight and range? That's a question you have to answer, right? Form factors. Give me prismatic. I don't want cylindrical. Give me pouch. I don't want this. Well, each one, again, as I said, has its own peculiar characteristics, right? So cylindrical, for example, is very energy efficient. In places where we have two-wheelers, where space is a premium, right? Or real estate, as we call it, is a premium, we would always go with cylindrical because I can pack in more energy, right? Prismatics, good, But where? I would say in high voltage applications, probably buses, etc. Although there are a lot of buses which are being done with cylindrical. And you tell Tesla that, who's using 18,000 cylindrical cells in his car, right? So polymers have their own advantage of volumetric efficiency, but then have a disadvantage of swelling, right? So your battery pack design, your thermals, everything changes, right? So let's not go with the myth that one form factor is superior over the other, right? It entirely depends on what product you're making, and probably more relevant to you guys would be the cylindricals. Next slide, please. Yeah. Battery pack cost. Now, I've borrowed this from Johnson Matthey Battery Systems. And what's interesting is people say cell cost to battery pack cost has a set ratio. And I want to say that it ranges. It can be 50%, it can be 70%. Are you putting active cooling? What level of safety? Active balancing, etc. What I really want to highlight is that battery pack engineering is a cost which has to be decided by the application that you are going after, right? If you are building a performance bike, be ready to have different electronics, different sets of cooling, etc. But typically, this graph will show you what makes up a typical battery system cost, right? You have the cell, which is the majority, and that's why we focus a lot on the lithium ions and the cells and things like that. Then you have the battery management system, the thermal management, the labor, logistics, etc. So the battery pack cost is a function of cell cost. So if you're talking about high cycle lives and high temperature, right, then you be prepared to pay more for cells, right? BMS. So a lot of people tell me the BMS should be this cost. Sure. But if you're talking about automotive grade components, which is ISO 26262, well, your cost is going to be more. So I think to have a mindset where a cost ratio is fixed is not true. You need to start from your application and then decide what is the ideal cost, right? Thermal design, of course, is one of the major contributing factors as well. Next slide, please. This is something which is most interesting. Depends on your warranty, your reliability, everything. How do we define cycle life? So somebody tells me, I want 2,000 cycles at X DOD, etc., and things like that, right? I want to say, go with the simplest method. And the simplest method on cycle life is Coulomb counting, okay? It's a universally accepted methodology which would take away your warranty matters, okay? So people talk about warranty in years, in cycles, and things like that. We have a very famous saying in the battery industry. Are you a battery maker or a battery faker, right? So it really depends. What conditions are you defining your battery at, right? So what is Coulomb counting? Coulomb counting is how much energy have I delivered from the battery pack over the life of the pack, okay? So I've taken an example. Let's say I've delivered 25,000 units. Right now, let's just keep it units, right? With about 2 Ah. So I'm talking about 50,000 Ah of energy delivered, okay, for the total life, okay? Let's say your battery voltage, we're talking about 48 volts here. We divide that, right? That's 2,400 kilowatt hours, okay? If you are talking about 1.5 kilowatts as your battery pack, right? Then you divide it by 1.5, and then you've got 1,600 cycles, right? So please specify cycles as Coulomb counting, because that will give you the most important thing. Because please remember that for the same battery pack, for the same amount of charge time, I could actually deliver less energy per cycle, right, as the battery starts aging. And that's one of the problems with lead acid, right? You start off, you're getting 80 kilometers for the same vehicle. In 6 months, you're getting 40 kilometers, right? And that's what's happening. End of life, etc., are big, topics for different discussions, but I wanted to kind of give you an idea of how we define a battery pack. So when we talk about cycles, let's talk about Coulomb counting. When we talk about C rates, this is the discharge rate. So many battery specifications talk about 1C continuous discharge, right? What do we mean by 1C continuous discharge? it basically means you're talking about 1 hour for the